Before I discuss this new rule, generalized power rule, I will revisit the power rule formula again. So in power rule, if I have this function x cubed plus 7, the derivative of this y should be 3x squared. However, if this function takes the form x cubed plus 7 to the power 99, then you can't just simply apply this power rule. Why? Because this x cubed plus 7 to the power 99 has 100 different terms, and it's almost impossible, to expand this polynomial. So in that case, this generalized power rule comes very handy. So again, just consider the general formula where I have f y equal to fx to the power n. Why did I write fx? Because this is no longer x, it's a function of x. So if you encounter a situation where your function is a function, polynomial of a function or function raised to a power, then you need to apply the generalized power rule instead of power rule. In fact, power rule is one example of generalized power rule. All right, so if this is what you have given, then the derivative of this function, which is dy by dx or y prime, should equal to n times f of x to the power n minus 1. So far, it's looked exactly like the power rule. However, when you change the value of x, it also changes the value of fx. Why? Because f also contains some term involving x. So if you change the value of x, it surely changes the value of fx. And that is the reason I need to take a derivative of this function f of x with respect to x and multiply this with this term. So in shorthand, I can write y prime equals to n fx to the power n minus 1 multiplied by f prime x. So you can clearly see the difference where y in power rule, if it's just x to the power n, and derivative of this is n x to the power n minus 1. But you might ask, where is that f prime x term here? So if I take the derivative with respect to x with x, it's going to be 1, right? So that is the reason we don't need to mention it. We don't usually mention this term because the value of this will be 1 anyway. So now let's consider one example. Maybe we can consider the one that I have already written here. So the derivative of this term should be 99 x cubed plus 7 to the power 99, just like here, n fx to the power n minus 1 times derivative of within bracket term, which is x cubed plus 7. So the answer should be 99 x cubed plus 7 to the power 98 times 3x squared. You can take other example as we can consider other example as well. Let's consider 7x cubed plus 8x squared plus 5 to the power 17. Again, this, if you expand this term, you will have, wow, many terms. So in that case, if you apply the generalized power rule, again life would be a lot easier. So what is that? So this power term n, which is 17 here, it becomes 17 times 7x cubed plus 8x squared plus 5 to the power 17 minus 1, which is 16, times the derivative of the within bracket term, which is 7x cubed plus 8x squared plus 5. One more line, 7x cubed plus 8x squared plus 5 to the power 16 times, if you apply the power rule here and here and the constant function rule here, you get 21x squared plus 16x. So this is a lot easier and more pragmatic approach when it comes to this situation. So now I'm sure you understand the difference between these two formula, the generalized power rule and the power rule. Again, as I said earlier, power rule is a special case of generalized power rule. Thank you.